What's up everyone, welcome back. Patrick here, moving on to the next video, more quadratic equations to solve with the quadratic formula. So just like in the previous video, I'm going to provide these solutions for these as exact values in case your teacher requires that. But then at the end, I'll also provide them as decimals. If your teacher doesn't require you to provide it as exact values to simplify the radical expressions, you don't have to worry about that part. You can just make sure that you're getting the same decimal values that I am. So let's start off with the first one. Actually, before starting off, let's do a quick review here. So if we have a quadratic equation like this, so we have a standard form quadratic on the left side, on the right side we have a 0, we know that x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula right there. So starting off with the first quadratic, we got 4x squared minus 9 is equal to 0. Now this one in particular, very easy to factor. If you notice, it's just a difference of squares. Okay, so we know what we're going to be aiming for. X is going to be positive 3 over 2 or negative 3 over 2. Those are going to be the two solutions right there. So let's see if we get those solutions that we just got with factoring with the quadratic formula. So here, notice that the a value is 4. Notice that the b value is 0, right? There's no bx term in the middle. And then the c value is negative 9. So plugging all of these here, we'll have x equals negative, the b value is 0, plus or minus 0 squared minus 4 times the a value of 4 times the c value of negative 9. And that's going to be all over 2 times that a value of 4. So we'd end up with, this just ends up being 0, so we end up with plus or minus 0 squared, which is just 0, minus 4 times 4 is negative 16 times negative 9 would give us positive 144. That's going to be all over 8, so we'd end up with plus or minus the square root of 144 over 8, which gives us plus or minus 12 over 8, which notice we could divide the numerator by 4, the denominator by 4, so we do indeed get plus or minus 3 over 2 for the two x values. So exact same solution that we got when we did it with factoring. Then moving on to part B, so we got 5x squared minus 11x equals 0. So notice this, another example of a quadratic that we can quickly factor. Notice we could take out an x. And so notice that the two solutions we get would be either x equals 0 or from this bracket x equals 11 over 5. So that's what we're going to be aiming for right there. So let's see if we get those same solutions using the quadratic formula. Now notice here the a value is 5, the b value is negative 11, and then the c value is 0, right? There's no c value at the end there. There's no plus constant like there was here, like a minus 9. So the c value is just 0. So let's plug in all of these into the formula. So we'd end up with negative 11 plus or minus the square root of negative 11 squared minus 4 times the a value of 5 times the c value of 0 all over 2 times 5. So we'd have positive 11 plus or minus. Notice this whole term goes to 0 because of that 0 right there. So we would just end up with negative 11 squared, which is 121. And then just the square root of 121 ends up being 11. Let me just write it though. I'll put 121, then we'll have 10. 11 plus or minus the square root of 121 is 11. That's going to be over 10. And so notice two solutions here. So x can either be 11 plus 11 over 10, or x can be 11 minus 11 over 10. So this would be 22 over 10, which would give us what? 11 over 5. And then notice over here we'll have 0 over 10, which would give us 0. So the exact same solutions as when we factored it. If you run into these kind of quadratics where it's just obvious that it factors, I recommend doing it as well, just so you can double check your answer. Again, not all quadratics are going to factor. That's why we're actually using the quadratic formula. One of the biggest reasons why we're using it is for quadratics that don't factor. but sometimes if you notice certain quadratics that can factor quickly, it helps to know what your targets are going to be. All right, so moving on to part C now. We got what? X squared minus 4x minus 46. So notice here the a value is 1, the b value is negative 4, the c value is negative 46. So we'd end up with x equaling negative 4 plus or minus negative 4 squared minus 4 times the a value of 1 times the c value negative 46. And that's going to be all over 2 times 1, which is just 2, like that. So over here we'll have 4 plus or minus the square root of 16, and then negative 4 times 1 times negative 46 would give us positive 184, and that's going to be all over 2. So this would be 4 plus or minus root 200 over 2, like that. And then, so let's write this out. Notice that the root 200 here, that actually simplifies. So if we take, let's do it on the side here. So we'll have root 200. We can actually rewrite this as root 100 times 2, which would give us 10, root 2. Okay, so this and this are the exact same thing. If you plug them both in your calculator, you'd get the exact same values. And so we're going to be plugging that in here. Again, just in case your teacher requires you to simplify these radical expressions. If they don't require, you can just skip this step. But I'm going to do it anyways, just in case your teacher does require it. And then you don't have to do it with the root 100, so you could do it in steps. Like you go root 4 times root 50 would give us 2 root 50, like that. And then the root 50, again, we can go root 25 times root 2, which would give us 2 times 5 root 2, which would give us 10 root 2. So ultimately, we end up with the same simplified solution, right? Over here, you're just going to have to use more steps. All right, so 10 root 2 is the same as root 200. So we'll have x equaling 4 plus or minus 10 root 2 over 2, like that. And then notice we could take out a 2 from the top. We could factor that out, so we'll have 2 plus or minus 5 root 2, right? When we factor out the 2 from here, we leave the radical as is, and we just factor out the 2 from the 10. So we end up with a 5. This is going to be all over 2. Notice those cancel out. So we end up with 2 plus or minus 5 root 2 as the answer. So the two solutions are x is 2 plus 5 root 2, or x is 2 minus 5 root 2. Okay, so if your teacher does require you to simplify, both of these solutions and both of those are the exact same thing. If you plug them in, you'll get the same decimal values, but notice how much more simplified that is. So if your teacher does require you to get there, that's the process. And so the two decimal values, if you want to get the decimals, would be 9.07, negative 5.07, and I rounded those. Right, so those are the exact value solutions. Those are the decimal solutions for part C. Moving on to part D, what do we got here? We got 16x squared equals 16x minus 1. So first thing we want to do, bring everything to one side. Right, so let's bring the 16x minus 1 over. So we'll have 16x squared minus 16x plus 1 is equal to 0. So notice the a value is 16, the b value is negative 16, the c value ends up being positive 1, like that. And so now let's plug these in into the quadratic formula. X equals negative 16 plus or minus negative 16 squared minus 4 times the a value of 16 times the c value of 1, like that. And that's going to be over 2 times that a value of 16. So when we do these, when we simplify this, this would be 16 plus or minus. Over here we'll have 256, and then we'll have negative 4 times 16 times 1, which would give us what? Negative 64, like that. That's going to be all over 32. And then we'll end up with, let's continue over here. So we'll have 16 plus or minus 256 minus 64 would give us 192, square root of 192 like that. And then that's going to be all over 32. And so from here, what we want to do, let's see if we can simplify that root 192. So we'll have root 192. Now, this will divide by 4. I think it'll also divide by 16, but it also divides by 64. So I think that's the highest rootable number we could divide it by. Again, you could divide it by these smaller rootable numbers, but then there's going to be more simplifying you can do. If you could find the highest rootable number that the 192 can divide by, which I think is 64 in this case, then you cut out a lot of steps. And 192 divided by 64 is 3. Root 64 is 8. And so root 192, 8 root 3, both of those are the exact same thing. So going back to here, 16 plus or minus 8 root 3 over 32. Notice that from the numerator, we could take out an 8, and we'd be left with 2 plus or minus. There's like a 1 left here, so it would just be root 3, like 1 root 3. We don't have to write the 1 there. All over 32. And then 8 over 32 simplifies to 1 over 4. So the final answer would end up being 2 plus or minus root 3. Give me a sec here. Yes, 2 plus or minus root 3 all over 4, like that. Okay, so this and this are the exact same thing, but this here is a lot more simplified, as you could see. So again, your teacher may not require that. If they do, that's how you do it. So the two solutions would be 2 plus root 3 over 4, 2 minus root 3 over 4, like that. Okay, so those are the exact value solutions. And if you want the decimals, those would be the corresponding decimals right there. To this quadratic equation, you could take both of those, plug them into the left side, and the right side, the left side, and the right side should equal. Okay, so that's it for part D. And then finally, we got part E and F. So with part E, notice it's already on the left side, which is nice. 6x squared minus x minus 1 is equal to 0. So let's write out these parameters. The a value is 6, the b value is negative 1, and then the c value is negative 1. I think this actually factors smoothly because I could tell 6 times negative 1 is negative 6. Two numbers that multiply negative 6 add up to negative 1 would be negative 3 and positive 2. Right? So this actually does factor, but let's focus on the formula first. So let's take this, plug it in there. We'll have negative 1 plus or minus negative 1 squared minus 4 times the a value of 6 times the c value negative 1. And then we'll be all over 2 times that a value of 6. So this would be 1 plus or minus, this would be 1. Negative 4 times 6 times negative 1 will give us positive 24 all over 12. 1 plus or minus root 25 over 12. 1 plus or minus 5 over 12, like that. So we'll have two solutions. X equals 1 plus 5 over 12, which would be 6 over 12, which would give us 1/2. Or we can get 1 minus 5, which is negative 4 over 12, which would give us negative 1 over 3, like that. So those are the two solutions right there using the quadratic formula. So there was no radicals in these. They're just rational numbers. There's no square roots there. Now, what if we were to factor this? I think what it's going to factor to, I'm going to skip some steps here. Let's just go straight into the decomposition. This would factor into negative 3x plus 2x minus 1 equals 0. We could take out a 3x. We could take out a 1. So then we could take out a 2x minus 1. And then we got a 3x plus 1. And so notice we could tell from the factored form, x is also 1/2, x is negative 1 over 3. Same solutions that we got with the formula. Whenever you get solutions like this that don't have like a square root attached to them, it means that the quadratic factors smoothly. So you could always check your answers if you get answers like this with factoring the quadratic. And notice that when we do that, we do get the factors that give us those corresponding same x value solutions. Okay, and then finally, moving on to part F. Part F is a little bit more tricky because we're dealing with fractions. Now, a couple of things you could do. If you want, you could plug in these values, an a value of a half, b value -2/3, c value -7 into the quadratic formula, but that's going to get pretty ugly because notice we're plugging in a bunch of fractions for a formula that's already in fraction form. So you can do that if you want. What I would do, I've mentioned this before in previous videos, when I have a quadratic equation with fractions, I like to multiply everything by the lowest common denominator to get rid of all the fractions. So notice the lowest common denominator between 2, 3, 1, and 1 is 6. So if I multiply this by 6, this by 6, this by 6, and then this by 6. So 6 times a half, 3. 2/3 times 6 is 4. 42, 0, like that. Okay, so the solutions to this quadratic equation, the two x values we're going to get, well, we'll see if we get two x values. I think we will. And the solutions to this quadratic equation are the exact same thing. Both equations are the same. Now, the quadratics are not the same, but the solutions to both of these equations are going to be the same. Because basically what's happening is, even though these quadratics may look different, they're actually still going to be going through the same intercept. So it'll be like something like this. The solutions, the zeros or the roots of both of them will be the same, even though these quadratics would look different if you just graph them alone. But if you did graph them alone, if you took this quadratic, graph them both in Desmos, you would see that they both go through the same x-intercept. So the solutions to both equations are going to be the same. And so what's nice now is that this has no fractions. So I would then get the parameters from that new equation, and then I would take that and then plug it into the equation. Okay, so again, you don't have to necessarily do that, but personally that's what I do. So then we'll have -4 plus or minus -4 squared minus 4 times 3 times -42, and then that's going to be all over 2 times that a value of 3. So from here, we'll have negative, which is 4, plus or minus, and then over here we'll have 16. -4 times 3 times -42, that would give us positive 504, like that, and that's going to be over 6. So we'd end up with 4 plus or minus root 520. That's going to be all over 6, like that. Now, if your teacher allows you to, you could leave it like this, but the root 520, that actually simplifies. So root 520, we could actually divide this by 4. We'd get 130, and then root 4 is 2. So root 520 and 2 root 130, those are the exact same thing. If you plug them both in your calculator, you'd see that they're the same decimal. Root 130, it actually doesn't simplify any further. Even though it just seems like a number, you could probably maybe divide it by 4 or 16 or 9. It actually doesn't divide by any of those. If you try to divide it by 4, by 9, by 16, by 25, by 36, etc., unfortunately, none of these are going to work, right? So root 130 doesn't simplify any further. And so let's erase this, continue here. We'll have 4 plus or minus, now root 520 I'm going to rewrite as 2 root 130. That's going to be all over 6. I could take out a 2. We'll have 2 plus or minus root 130. And then that's going to be all over 6 like that. And then 2 over 6, that simplifies to 1 over 3. So we end up with 2 plus or minus root 130. That's going to be over 3, like that. right? So I erased it, actually, it was there before, but that first one that we had, 4 plus or minus root 520 over 6, and this, those are the exact same thing. The decimals would be the same, but again, this is more simplified here. And then if you want, let's write out the two solutions separately. So we'll have x equals that, then 2 minus root 130. That's going to be over 3. And then if you also want to get the decimals, those would be the two corresponding decimal solutions for this quadratic equation like that. All right, so personally, if I got fractions, I change it. I multiply everything by the lowest common denominator to get a new quadratic equation with no fractions. Then I plug in those parameters and the solutions should be the same. Right, so just a couple of other different scenarios of where we're solving equations with the quadratic formula.